discuss how you can make your existing HVAC systems more pandemic ready by using this technology we manufacture called needlepoint bipolar ionization. This technology is being used currently all over the world in various applications. Now, as it relates to COVID-19, it's certainly seen an uptick in recent months with everybody worried about trying to get their employees and their clients back into their buildings, and on the aviation side, back into airplanes. And so we'll talk about the technology, how it can impact COVID-19, as well as other indoor air quality items that you may be concerned about if you're designers and contractors on the phone. So currently we have over 1,000 K through 12 schools using our technology, and a lot of the school systems are using it to reduce their outside air requirements. In healthcare applications, we're not able to reduce their outside air requirements because they're following a different set of guidelines. But in schools and non-healthcare applications, you're able to clean the air, recirculate the air, because you're using this technology to remove the contaminants of concern instead of using more outside air to dilute the contaminants. And so within ASHRAE 62, you have the ventilation rate procedure, which is what I call the dilution method. And you also have the indoor air quality procedure that's been there since 1981. And that procedure requires you to run a mass balance analysis, which we have software that will do that for you. It will calculate the outside air required if you don't use air purification systems. It will also tell you how low you can go with your outside air requirements subject to your building pressure using this technology. So as you can imagine, if you're designing a new facility and you can reduce your outside air requirements, that will have a significant impact on first cost because you downsize the chiller, maybe the DX equipment, maybe the outside air equipment that has to treat the outside air, dehumidify it or preheat it before it's dumped into the sensible air handlers. And so there's a lot of savings involved with that. On the healthcare side, as I mentioned, the technology is not used to reduce the outside air requirements, but it is used as a replacement to UV lights, as well as a replacement to carbon. It always seems that in healthcare applications, you have helicopters landing, you have diesel generators being tested, and those odors are being pulled into the building. And this technology can be used as a replacement to that carbon in those applications, as well as a replacement to the UV light to keep the coils clean and treat the space as well. We've done a lot of high occupancy areas like sports arenas, hospitalities, hotels, motels, and then worldwide over 150,000 installations. So here's a short list of some of the hospitals that have utilized our technology over the years. As I mentioned, some of them are using it as a replacement to carbon. And with carbon, you actually have to tune the carbon. You have to select the right carbon for the application. If you don't do that, you could have a huge mass of carbon in your air handler and it does not control the fumes effectively. So with carbon, number one, you have to tune it. And also it likes to absorb water vapor before any other contaminant. So a lot of times in hot, humid environments, it's used the majority of its capacity on the water vapor versus the contaminants you're really trying to pull out of the air. And so with our technology, you don't have to tune it. Also with carbon, you have to put in a final filter in most applications to capture any dusting that may come off of that filter. And that's another pressure drop in the system. So now you have two maintenance items because of the carbon. The carbon itself has to be replaced as well as the final filter to capture the dusting. So you don't have either of those items with this technology, and it can be easily substituted for those types of odor control applications from the helicopters, the generators, trucks idling at the loading docks, things of that nature. Also, this technology is being used as a substitute for ultraviolet light. Now, a lot of times UVC will be utilized, but it's generally mounted on the leaving side of the coil and it's over top of the drain pan because the light can only kill what it shines on. And so therefore, if you put these UV lights into your system and you're trying to control COVID-19 in the space, because that's where the actual COVID-19 is, it's going to have no impact whatsoever on the virus in the space. I have found no research anywhere that actually shows that viable virus is actually getting back to the filtration system or UV light systems in these larger HVAC systems. What's being shown is that the virus is airborne and it is transmitting 20 and 30 feet, but it's not really getting all the way back into the HVAC systems, at least not viable strains of it. So maybe there will be new research that comes out that proves that it is going to be getting back to the filters, but right now that's just not the case. So by using UV lights inside of the air handlers, you're not going to have an impact on the virus in the space. And so I just wanted to point that out. So these are some of the clients using our technology. One in particular I like to point out is AI DuPont Hospital. They've been using our technology for a few years now, and they put it in originally because they had some mold issues in their space, and they put UV lights everywhere throughout the hospital inside of the air handlers. Well, the UV lights had no impact on their particle counts and their mold spores in the air down in the space. Once they put our technology in a couple of their critical areas like the NICU units, they saw a 90% reduction in total particle counts and mold spores in those areas. So they were very impressed with those results, and therefore they started putting it throughout the facility. Just a couple months ago, they actually put it into their ORs and they did a pre and post testing, and they saw a 70% reduction in total particle counts, even in an operating room where you have 20 plus air changes per hour and HEPA filters. And so this technology really can go after those ultrafine particles, make them get larger to where the airflow can push them around more effectively and get them captured at the filters. So they saw a big particle reduction in the operating room, which is deemed a sterile environment. They also saw a large reduction in airborne viable bacteria, which was also critical in these applications. We did the White House about 2 years ago, at least the east wing of the White House. We have not done the west wing yet. It was an upgrade to the HVAC systems in the east wing, and the General Services Administration recommended and specified our needlepoint bipolar ionization instead of UV lights to keep the cooling coils clean, as well as to treat the air within that side of the White House. We've also done a lot of higher education applications, and some of these clients are using it for mold control in their dormitories. Some are using it for outside air reduction in their high occupancy areas, maybe their gyms, larger classrooms. And then some are just using it to enhance the indoor air quality and increase their filtration within the system. We also have an aviation division, and I bring this up because we've passed DO 160. So that means if you're incorporating this into areas in a hospital that may have medical imaging equipment and you're worried about line noise or EMF or something that could disturb the operation of the medical imaging equipment, this technology is not going to do that. It's certified as EMF line noise free. We don't interfere with the avionics on the plane. We won't interfere with your medical imaging equipment in a healthcare application. And so I just wanted to bring that up. We have a lot of airlines now using the technology on the general aviation side. And then we have the commercial airlines are very interested in the technology now because one, we do have COVID-19 test data on specifically the COVID-19 strain. It's not just a human coronavirus surrogate. We actually have that data. And so the airlines have two major issues right now. One is the COVID-19 issue. You're putting a lot of people onto this long tube that's recirculating air. And so people have the opinion that they could get infected if they go back to flying again. And the second issue is the PR issue, is to making people feel comfortable returning to the air on the airlines. And so the airlines are trying to figure out ways to combat both of those issues, and this technology is appearing to be a solution for both of those for the major carriers. So hopefully you will see in the news very soon where one of these carriers have moved forward and are going fleet-wide with the technology. We have a lot of military and government users of the technology, especially on the airplane side. We've done the most VIP aircrafts around the world. We do a lot of aircraft upgrades with the ionization technology throughout the world as well in all branches of the military. We have done a lot of large office space clients. Here we have Google in Chicago and San Jose. Can you hear me, Brad? I'm not sure if anybody can hear me because it came up as I was muted. So hopefully I'm unmuted and you
we hear you.
Okay, thank you. Thanks. So we've put this in to Google prior to the COVID-19 outbreak, and this technology is being used as a way to make the workers and the clients feel more comfortable coming back into their buildings. So return to workplace safety is what a lot of people are talking about now. You'll hear people talking about how you can call elevators using apps on your smartphone. You don't have to touch anything. You'll hear people talking about how to disinfect the spaces, the surfaces in the space. Well, what is left behind is the air quality in the space. How do you disinfect the air where the actual COVID-19 virus is currently residing? And that's when people are talking, sneezing, and coughing. The virus is down low. It's in the space. It's not getting back to the air handling system. So even if you have a HEPA filter and a UV light system, as an example, that's 100% efficient at all particles and all pathogens, they still have to get to those devices to work. Versus this technology is an active technology that's coming out into the space to help control these contaminants out in the space. So office space is a great application. Airports, great applications where you have odors from the jets and the helicopters and the tugs pulling the carts around with the luggage. We have a lot of airports using the technology. They've reduced their outside air in some of these applications. We also have them using it as a replacement to the carbon. We understood that Phoenix was spending over $500,000 per year in carbon replacements, plus over 1 inch of water column pressure drop to pull the air through the carbon. So by using this technology, they were able to eliminate that carbon expense and the pressure drop and save that energy. And now they have no odor complaints, even in some of the worst areas where they were getting the most complaints from some of the admin people. Now, as I mentioned earlier, we use ASHRAE Standard 62, the indoor air quality procedure, to clean up the air in your building by using this technology such that you can recirculate it. It takes care of the contaminants of concern, and you can reduce your outside air requirements. And we do have software, which we're not going to get into today for the sake of time and go through that, but we do have software that will calculate both methods, the VRP and the IAQP. And what's nice about the software is that you don't need to have any more data to run the indoor air quality calculations than you already need to know in order to design with the ventilation rate procedure. The one thing I do want to point out here is that as of 2019, ASHRAE 62.1 2019 requires UL 2998 certification for air cleaning devices. So it doesn't matter if it's UV lights, if it's electrostatic filters, or if it's ionization systems like what we manufacture. If you have voltages in your system that exceed 480 volts, you're now supposed to be certified to UL 298 to be compliant to ASHRAE, which means you don't generate ozone as a byproduct. And the reason why ASHRAE felt it was necessary to force UL 2998 certification is that the UL 867 standard was not adequate as it pertains to electronic air cleaners. Electronic air cleaners are certified to UL 867, but all of that standard really gives you is the ability to know that when you plug it into the wall, it's fused properly, everything's going to work, it's not just going to catch on fire. So it's a safety electric standard. But if the unit was a portable room unit, it would have to be tested for ozone. And the ozone chamber in this particular test was approximately 1,000 cubic feet, which is 10 feet by 8 feet by 12 feet, and those ballpark numbers. And so you would put your device into the room, you would measure the ozone 2 inches away from the output of the device, and over 8 hours, you could not exceed 50 parts per billion of ozone with the technology. However, there was a huge loophole there that stated if the products are designed for duct mounting, you don't have to be tested for ozone. So we have a lot of competitors out there in the market that make ionization systems that claim they're ozone free and that they're 867 certified to UL, so all is well, but they don't have the ozone certification because they are duct mounted and they don't have to be tested for it. So ASHRAE said, wait a minute, we've got a problem. We want to make sure that all products are ozone free, whether it's portable units or if it's a duct mounted system, because if you generate ozone in the duct, ozone has a very long half-life, even up to hours. And so if you're generating ozone, it can get to the space where people can breathe it in, and that's what they don't want. And so with 2998 certification, you use the same chamber as 867, still measuring 2 inches away, but it doesn't matter if the products are duct mounted or portable room air cleaners, they now have to be certified to produce no more than 5 parts per billion. So we're 10 times lower in ozone levels, which is really even lower than background levels outdoors if you were to go outside and measure ozone. And so that does apply to UV lights, polarized filters, ionization systems. And so they're all supposed to have this 2998 certification to comply with the latest edition of ASHRAE 62, section 5.7.1. And so I'm saying all this just to kind of get you educated on the UL standards. And when you start seeing other competitors in the market talking about they are UL certified, they don't produce ozone, ask them for the UL 2998 certification. Just like you see the commercials for the Carfax, you ask for the Carfax when you're going to buy a used car. Well, ask for the UL 2998 certification if you're specifying or purchasing ionization type systems or electronic air cleaners in general. So this technology has actually been around quite a long time. The earliest concept goes all the way back to 1879, which predates ASHRAE. ASHRAE started around 1895. And this technology was developed by Sir William Crookes. He called it the Crookes tube, which obviously isn't the best name to be out marketing the technology. They ended up changing the name, and they changed it to the plasma tube in around 1928. And this plasma tube is how you see it there in the photo. It's a glass tube, and you could have a mesh screen on the inside, just like a filament in a light bulb would be. You have the mesh screen on the outside of the tube, which is grounded. When you apply a high voltage into that inside electrode, it goes up through the mesh screen. It breaks down the glass dielectric to get to this ground on the outside. That completes the electrical circuit. And when that happens, you get this corona discharge. That's why it's called corona discharge or dielectric barrier discharge. The dielectric can be glass, ceramic, mica, or a composite material. But bottom line, in order to make that material break down and allow the voltage to get through it to complete that electrical circuit, you have to put more energy into that tube than oxygen, which oxygen's energy level is at 12.07 electron volts. If you ionize oxygen, you always get ozone as a byproduct. So that's why this older technology will always generate ozone as a byproduct, no matter what, if it's on and operating, as well as creating the ionization. So that was the downside to the old technology, was the ozone produced as a byproduct. You also had a tube that would wear out and would have to be replaced every 1 to 2 years, just like a UV light system. Now, what we've done with our technology is we've taken this old tube concept and we've converted it to needlepoint bipolar ionization. So we have eliminated the actual composite material. There is no dielectric in our system. Here you can actually see the carbon fiber brushes, and each individual carbon fiber brush acts as an ion emitter point. So in that one brush cluster, you may have well over 1,000 individual needles that are emitting the ions into the airstream. And these ions are emitted based on the polarity of the voltage being applied. So if it's positive, it's going to be positive voltage. If it's negative, obviously negative. Some of the systems that we provide are also bipolar. So each individual brush cluster flips between plus or minus based on the frequency being applied. But because we don't have this dielectric, we don't ionize oxygen because we can control the power input into the airstream. So that's how we are able to achieve that UL 2998 certification, as well as the FAA certification, the DO 160, in order to put this on aircraft, because they do not want ozone added to the cabin of the plane. So within needlepoint bipolar ionization, we like to use the acronym NPBI, just to kind of shorten all that down. But you have direct current systems and you have alternating current systems. Direct current systems will have the electrode stay the same polarity 24/7. So what that means is, as particles are moving through the air, particles that are oppositely charged are going to hit that electrode and stick. So over time, you're going to see the electrode start getting dirty. And for that reason, we've developed these auto cleaning systems. So every 3 days out of the box, this wiper blade turns on and rotates, and it cleans these brushes off automatically. So there's no maintenance to the systems, and there are no replacement parts with our systems. So that's a huge benefit to the owners, and especially as it relates to COVID-19, you want the ion density at maximum all the time. So you don't have to worry about a maintenance crew going out and cleaning the systems to maintain their output. They maintain themselves all the time. And so with a DC system, it's highly important to have this auto cleaning feature, as well as I want to point out with the DC system, that really only refers to the output. The input voltage to power the system can be AC or DC. And one thing that's unique about our technology with the auto cleaning systems is that they will accept AC or DC, and they accept a wide range of voltage, 24 volts all the way up to 240 volts, AC or DC. You simply bring voltage to our equipment in that range. It senses what you've connected and it regulates to that. And one thing to point out is it doesn't matter if you have 24 volts connected or 240 volts connected, it's going to provide you the same high voltage output, because we don't want to exceed that level for oxygen because you don't want to generate ozone as the byproduct. The second type of technology we provide is the alternating current systems. So we have these modular bars, and these sections come in 6-inch sections, and they snap together for whatever size you need for the size air handling system that you have. So here we have a carbon fiber brush, and that brush alternates between plus or minus based on the polarity being applied and the frequency being applied. In North America, the frequency out of your standard outlet is 60 hertz. So 60 hertz equates to 60 times per second. This is alternating between plus or minus, and so it's static neutral. So that means that particles are not attracted to it, so it stays clean, and it's somewhat self-cleaning because it's an AC device. In addition, these brushes are recessed behind the peaks of these waves. And so particles don't directly impact the brushes as they're moving through the air. And without the static charge, like in the DC type system, you don't have particles drawn to it, so it stays clean. These ions that we're creating are naturally occurring. If you go high in altitude or if you go to a waterfall and you measure the ion levels, you generally measure around 5,000 ions per cubic centimeter out in that atmosphere. If you go inside of a city and measure with the ion meter, the pollution from the buildings and the traffic react with those ions and they reduce the levels even further. And then inside of a building, you will have less than 100 ions per cubic centimeter because the filters in the building take the particles out of the air, but they also take the ions out of the air with it. And when these ions are generated, you have up to 60 seconds in order for them to react with something in order to control particulate or kill pathogens down in your space. We always recommend mounting these devices after your particle filters so they can treat on further on downstream. So when you leave the presentation, I would like for you to remember the acronym POAP. Particle reduction through agglomeration. We make these particles get larger. Think of it like individual snowflakes forming into snowballs. As the snowball gets larger, it gets surface area, and now the airflow can push against it and get it back to your filter where you get it out of the air. We control odors through oxidation. We break down these gases and odors in the airstream by imparting a certain electron volt potential into the air. We use 12 electron volts. That's no secret with our technology. That's just below oxygen, so we don't generate that ozone. And we convert these contaminants with electron volt potentials of less than 12 back to what's prevalent in the atmosphere: oxygen, nitrogen, water vapor, carbon dioxide. The technology also kills pathogens and as well as saves energy. And we'll talk about each one of these in a little bit more detail. So the first benefit is particle reduction. And as it relates to COVID-19, there's a lot of reports out now. Just 2 weeks ago, I received 5 more reports about particles being a transport mechanism for COVID-19. This one report, obviously you can see this is a picture of Italy. The areas of Italy that had the highest pollution as far as particles also had the highest transmission rate of COVID-19. Now, one of the reasons for this is that when you cough and sneeze out this really small particle, it can hit a larger particle, and then that has the surface area, like that snowball analogy I gave you, to push that particle greater distances. So by reducing these particles that could make up a sunbeam in the afternoon or the morning, you've reduced the transmission ability of COVID-19 in the first place. So when you put this technology into your home, if you have sunbeams in your home right now in the afternoon or in the morning, after 2 to 3 days of operation, you won't have the sunbeam anymore. Those positive and negative charges travel with the airflow out into the space. They hit those particles and they charge them. As the particles become charged, the oppositely charged particles stick together and start growing larger. So you take something the size of a BB, turn it into a softball, and get it back to the filter where it can be captured. And that's just another analogy at the molecular level. Obviously, you're not going to make them that large. But as these particles get larger, they get pushed a lot easier by the system's airflow. So over 2 to 3 days, you won't have a sunbeam anymore. And that could be pet dander, pollen, mold spores, virus, bacteria, sand, dirt, all that stuff that's kicked up into the air will be removed. And then if it's not in the air, then as far as from inhaling the virus or inhaling that air, it's going to be a lot cleaner, and it's going to have a positive impact on your health, because that stuff is what typically triggers asthma and allergies in these systems. So to give you another idea of how the system works in real time, this is a smoke video. Half a cigar has been smoked in this small chamber with a kerosene pump. And then when he flips the switch, it'll count down 3 seconds, and you'll see 3 to 4 seconds worth of time go by, and the smoke just swirls and disappears. There is no fan and there is no filter in this container. It's simply the ion generator with the electrodes up inside of it. And those ions make the smoke swirl. It makes the particles charge the smoke particles, and they stick together. And as they get larger so fast in this really confined area, gravity takes over, and gravity makes these particles just drop right out of the air. 1, 2, 3. So there, in just a matter of a few seconds, you can see how the smoke disappears. So this would be representative of your sunbeam. You put this in your home, you make the sunbeam go away, but what's nice is you keep the ionization running. Even when you have other particle sources in the space, it maintains those particles. It keeps the agglomeration process going, and it maintains them, and smoke cannot build up once you have these systems in and operating. So that's a huge advantage to this technology. Now, as it relates to particles, I think it's good to have an idea of what these different particles look like in real terms. So 1 grain of sand is 90 microns in diameter approximately. Human hair is 50 to 70 microns in diameter. PM10 refers to particle matter that's 10 microns and less, so that actually includes PM 2.5. And then particle matter 2.5 is everything 2.5 microns, typically down to 0.3 microns. And then on this scale, I've tried to show COVID-19. Right here is that little black dot. So COVID-19 is 0.125 microns, but with COVID, when you cough and sneeze it out, it's generally covered with mucus. And so it's a lot larger, it's heavy, and it drops out of the air fairly quickly. But now they're finding that, especially in lower humidity environments, less than 40% humidity, the mucus that surrounds it can evaporate rather quickly as it's settling to the floor, and that leaves the virus exposed to stay in the air a lot longer. And according to ASHRAE's infectious aerosol paper, the smaller the particle, especially in a room with no air movement, the longer it's going to stay in the air. So a 0.5 micron particle can stay in the air for 40 hours or more with no air movement. So with these particles, when you cough and sneeze them out, which doctors are now claiming that if you sneeze and you don't cover your sneeze properly, you can launch over 200 million of these viruses into the air. So that's why it's important to cover your sneeze and wear a face mask, especially if you're sick or going out into public. Now with COVID-19, another reason why it's impacting us so bad is that the people that inhale the virus, it can get deepest down into your lungs. And so here you can see this chart from ISO 16890 shows us that the smaller the particle, the deeper it goes into your lungs. So if you can agglomerate these particles, and if you can make them get larger, then your own body can help fight them off much better if you can keep it in your upper respiratory system versus allowing it to get down into your lungs. Now, as it relates to COVID-19, I've been seeing a lot of research, and I've seen 3 theories float to the top. And I want to state theory because it's not proven science yet, but in 5 years, we'll probably have better answers. The first theory in regards to how COVID-19 is transmitting is based on how you become sick. How you contract the virus determines how sick you get. So if you inhale the virus and it gets deep into your lungs, those are the people that are likely the most sick and die from the infection, because your body has to work even harder and it can get into your bloodstream once it's down at your lungs. The people that get sick by touching an object and then touching their face and becoming sick, that's more like an upper respiratory infection. The second theory would be genetics. Everybody has a different genetic code, and based on how sick you get, depending on your genetic code, that will determine how sick you get because your body's better at fighting the virus than others. The third theory is simply your age and any underlying health conditions. And so if you have underlying health conditions, that can vastly contribute to this virus hurting you even more. And so those are the 3 theories that I've been hearing out there in the market right now. Now, with our technology, when you ionize the air in the space, even in a clean room environment, so pharmaceutical applications like this can see a huge reduction of particles. Here we have a clean room manufacturer using, this was actually catheters in this clean room being manufactured, and they saw almost a 90% reduction in total particle counts, even in a clean room environment with a very high air exchange rate using HEPA filters that were 99.99% efficient. And so we can impact those ultrafine particles. We also have a lot of independent testing that shows taking an existing filter and simply adding our technology into the system will make the filter more efficient. So right now, ASHRAE is recommending through their COVID-19 task force to increase your MERV ratings up to a MERV 13, which is not a bad idea. But the problem is if you go from a MERV 8 to a MERV 13 and that pressure drop goes up because of the filter media being more dense, if your supplier actually goes down because the fan cannot handle the additional static pressure drop, your total particle counts are likely to go up in the space. So even though you have a more efficient filter, particle counts can go up in the space if the airflow goes down, which impacts the total air exchange of the space. We did some testing quite a few years ago. We were looking at coming out with a portable room air cleaner, and the same fan and motor with a MERV 8 filter in the AHAM chamber gave us a better clean air delivery rate by almost 50% than the same system using a true HEPA filter, which had a huge pressure drop, and it slowed the speed of the air down. So the air exchange rate went down in the chamber. So that actually was counterintuitive for me. When I put the HEPA filter in, I thought we were going to see a much better clean air delivery rate, but it comes down to the air exchange rate, and that highly impacts the particle removal in the space itself. So just keep that in mind if you're looking to upgrade from a MERV 8 to a MERV 13. you can actually upgrade to a MERV 13 just by adding this technology, which adds no pressure drop to the system. Also, the NRC in Canada found that a MERV 12 filter with our product made that MERV 12 filter have the efficiency of a MERV 16. So here in the US, we're using a lot of MERV 13 filters as final filters. MERV 13s would become 16 or 17 into that actual HEPA filter rating. Another benefit here is that ionization removes the ultrafine particles. And this study was from 2017, Journal of Electrostatics. This is a peer-reviewed publication. And you'll find that air ionizers are more suited than high-flow air filters. So they're talking about HEPA filters in this application if you read the study. And they were able to remove more ultrafine particles in these larger spaces than what the HEPA filters could in the systems. And that's because these ions go out into the space, they seek out these contaminants, and they agglomerate them and get them moving back to the filters for removal. So that was a huge benefit. So 25 cubic meters is a space that's about 10 by 10 and 9 to 10 feet tall. So that's going to be the equivalent of 25 cubic meters worth of air volume. So if your space is larger than that, then you would actually have more impact by putting ionization into your systems than putting in just a portable room air cleaner to try to control the contaminants. The last benefit I would like to talk about with ionizing the air is that it increases face mask efficiency. And based on this testing from the University of Cincinnati in 2005, they found that by ionizing the air in the space, an N95 respirator became 48% more efficient. A surgical mask is 194% more efficient. And then you can see over 3,000% for the dust respirator. So the lower the efficiency of the material, the more impact this technology actually has on the material itself. And one thing I would also like to point out is that I've seen a lot of hospitals sterilizing their masks and reusing them, which is a bad idea in my opinion, because these N95 respirators are typically provided with a static charge on the filter material to enhance it to get it up to that N95 rating. As you wear the mask, the humidity from your breath reduces that static charge, and that's why it's designed for one-time use. And especially when you go and sterilize the mask with either steam or vaporized hydrogen peroxide or something of that nature, you actually remove that static charge and it's no longer going to be achieving this N95 rating. So just be cautious of that. If you're working with clients that are sterilizing masks, let them know that those masks may not be that N95 rating. And even with ionizing the air, we may not be able to hit that N95 rating again, but we can get closer to it. So the first benefit was particle reduction in the acronym POPE. The second benefit is odor control. The odor control comes from the fact that we break down these gases based on their electron volt potential. So over on the right side, you can see that every gas on the list has this EV. Every gas in the atmosphere has an electron volt potential that's specific to that particular gas. When you impart more energy into the airstream than the electron volt potential of that gas, you oxidize it, you break it down, and you convert it to what's already prevalent in the atmosphere. Now with our technology, you see this red line, that's at 12 electron volts. So everything below 12, we can break down effectively. Everything above 12, we do not, because the energy is not high enough, which we specifically turn it off there because we don't want to ionize oxygen in this application. When you do that, you get ozone, and that's an undesired byproduct, which all of these older systems are going to create with the glass tube, because for them to conduct electricity, they have to operate slightly above this threshold. The third benefit in POPE is pathogen control. So the positive and the negative ions disrupt the DNA and the RNA structure. So you have a genetic code as it relates to COVID-19, that's an RNA genetic code. We disrupt that genetic code, so even if you inhale the virus, if the code has been disrupted, it cannot tell your body how to replicate itself. It's no different than a computer virus getting into your system and screwing up your code in the system and not allowing your Windows or your Mac to run properly. So that's what this technology is doing, as well as what UV lights do, is you disrupt the DNA and the RNA genetic code and it cannot replicate, and that's important. When it comes to bacteria and actual mold, that typically has hydrogen in it, and we end up removing the hydrogen from the cellular wall, and it spends its life trying to repair itself, and it cannot reproduce. So I tell people it's like hand sanitizer. It kills the germs on your hands, but it does not kill your skin cells. And specific to our technology, having UL 2998 certification as an ozone-free device, we're not injecting any other contaminants into the airstream that could be harmful to your health. We're simply recreating those nice environments with these higher levels of positive and negative ions in the space. And we've had a substantial amount of research conducted on our technology. We have EMSL Laboratories, ALG, and Innovative Bioanalysis. Now, innovative bioanalysis is the most recent testing, and I'll draw your attention to the bold feature here, COVID-19. To my knowledge, we are the first company with the technology to be tested against actual COVID-19 virus. This is not human coronavirus. It's not a surrogate. You'll see a lot of my competitors saying that they kill 99% of the coronavirus, but they've not been tested to actual COVID-19. They are generally being tested to 229E, which is simply a human coronavirus strain. So because of our aviation affiliation, we were able to score some actual COVID-19 with a government facility and get this testing completed. So in 30 minutes, this technology was able to inactivate 99.4% of the virus. And from the time they turned the devices on, the actual inactivation rates were starting. And the first timestamp they took that was official was 10 minutes and was already in the 84 percentile. And then at 15 minutes, it was already in the low 90s. I believe it was 93%. And then in 30 minutes, we were at 99.4. So we're already over a 2-log reduction just in 30 minutes. And so this is very impactful when it relates to COVID-19 because we're looking for solutions and we actually have the data to support what we're claiming with the technology. And based on the time exposed, that's going to determine the inactivation rate of the virus. So when you think about this, and again, what you may see from ASHRAE and other organizations recommending HEPA filters or MERV-13 filters in the ductwork using UV lights. If you put UV lights in the duct, if you put HEPA filters in the duct, that's not impacting the virus in the space. This impacts it in the actual space where you have the problem. Now, this slide was actually out of a presentation in 2009 from the EPA, and it's talking about the SARS coronavirus, which was the problem back then. And so if you only use filters, a MERV-8 filter, assuming the virus can get back to the filter to be captured, and that's the big assumption here, that filter could stop 11% of it. A MERV-13 filter, 46%. If you combine UV lights with that system, you now can get 19%. A MERV-13 jumps you to 84. But what's interesting is we have a MERV-8 filter. You're now 84% because of that agglomeration feature of the technology. We're increasing the filtration efficiency of the system, and we're treating these contaminants out in the space. A MERV-13 filter is looking more like 97%, and it just becomes even more efficient above that. If you are using UV lights, just make sure, or any other technology that does require maintenance, make sure you're doing the maintenance on it. Here's a picture of a UV light that was sent to me from a prominent hospital down in Texas, and they actually have mold growing on the UV light. Now, I was told that when this picture was taken, right before they opened the door to the air handler and the door switch killed the light was still glowing blue. The problem with UV lights is that from the day you plug them in, the output, the germicidal wavelength is diminishing. And so after 2 years approximately, you're not going to have enough germicidal wavelength to kill, especially mold. Mold's one of the hardest things for UV lights to kill. And so if you're not maintaining the systems properly, this can happen. So don't wait 4 years to replace your lamps. Make sure you're maintaining them properly, or this can happen. Just like with any system that requires maintenance, you have to do the maintenance. And so with our technology, it does not decrease over time. So you don't have to worry about maintaining bulbs. There are no replacement parts with our systems. The reason why you generally see UV lights over the drain pans and on the wet side of the coil is because that's where the biofilm grows. With our technology, we mount to the air entering side of the coil with our ionization bars that covers the entire width of the coil. And the reason why we want to do that is we want to treat the entire depth of the coil. If you mount the ionization bars downstream, like where you mount the UV lights, then the ions do not swim back upstream and hit the coil. They actually move with the airflow, just like if you were injecting humidity into the airstream with humidifiers. Humidity flows with the airflow. It does not swim upstream against the airflow in these air handlers, generally speaking. And so with this technology, we're able to keep the coils clean, which impacts your heat transfer. So we're going to keep the load on the chiller down versus allowing the biofilm to hinder that heat transfer. In addition to the heat transfer savings, you also get savings in the fan and the energy of the fan because the fan has to work less hard to pull the air through the coil. Some of these coils that I've seen in the field, visually, they look great. They look clean on the surface, but if you actually cut that coil in half and look at a side profile view, from years of power washing the coils, you've compressed a lot of that biofilm right into the center of the coil, so visually you can't see it. It's hard for the UV lights to even get into it, especially into a deep coil. So that's why this ionization before the coil is nice. It goes through the entire depth of the coil and treats the entire depth of the coil. And here's an example of a hospital down in North Carolina that had yellow mold growing everywhere on this cooling coil. And this was actually feeding the operating rooms, but they said they had HEPA filters downstream and they weren't concerned really about the mold. They actually put this technology in to control fumes from a new helipad as well as a loading dock with some diesel trucks that were idling. But 3 weeks later, when we came back to just discuss how the systems were operating, this is what the same coil looked like with no mechanical cleaning between day one and the 3 weeks out. It's killed the mold that was growing, and when the coil is condensing, it just washes that mold away right down the drain. So no mechanical cleaning between the before and after. So you can imagine how much heat transfer that mold was impacting on the coil versus now. We did a hospital out in Alabama that had over 4 inches of pressure drop, and we took the 4 inches down to 1 inch over a period of 6 months. It was a really packed coil. They were about to just replace it. And we said, if you can work with us, we'll give you the system. Let us get the data. So it went from 4 inches to 1 inch over 6 months. And the heat transfer went from over 60 degrees leaving air temperature back down to 52 degrees. And so it was a huge reduction in leaving air temperature. They can now maintain their temps, and also the efficiency of the system went up. Here's an example of just an experiment to show you, and visually, what all of these reports that we can provide you for our testing confirms, but in just a very quick visual format. So act like this bread would be your cooling coil in the system. So on the right side, we're ionizing the cooling coil. We're keeping the mold from growing. And on the left side, this coil doesn't have any ionization. So using time-lapse photography, you can see the mold starting to grow in real time over on the left-hand side. And on the right side, it just proves that in the presence of the ionization system, mold cannot grow. And so a lot of our clients, pre-COVID-19 anyway, were using the systems just for mold control in their spaces, especially in areas of the country and school systems that they leave for the summer, and when they come back, mold's everywhere because humidity got out of control. So this is one way to control mold even in high humidity environments. So we've talked about particle reduction, odors, and how it controls pathogens. Now here's some of the technologies that you can use based on your system type to control these contaminants. So the first one is designed for your high wall ductless mini splits. So we have what's called the iRib. It's 18 inches long or 36 inches long, and it just lays across the top of your cooling coil on these high wall units. You wire it into 110 to 240. It doesn't care what it is. It just senses it and runs. And it's only 2 watts. So we recommend just leaving it on 24/7. And that also simplifies your installation and takes away the building control interface to try to interlock it with your fans. Since we don't generate ozone as a byproduct, it doesn't matter that it's sitting here operating when the airflow is turned off. You don't get this huge cloud of ozone dumped to the space because we're not generating it. The next product is the FC24. It stands for fan coil, 2400 CFM capacity up to that. So anything up to 2400 CFM, and it's auto cleaning. So every 3 days out of the box, this wiper blade spins and it cleans those brush tips off. And so there's no maintenance to these systems, and there's no replacement parts. These motors are life cycle tested to over 8 million cycles before failure. So even if you press this little button here in the field and you reprogram that unit to clean every single day, that's over 120 years of life that you get out of these systems prior to failure based on this life cycle testing. So it's actually a robotic stepper motor designed for high torque and continuous duty, and they're only being operated once every 3 days, or worst case, once every day for 5 cycles back and forth. Here's what it looks like installed to a fan inlet. So this could be fan coils, heat pumps, small air handlers, could be even VAV boxes if you're trying to treat specific zones off of a larger air handling system, or fan powered boxes. Those are good applications for this device. It's also only 1 inch in depth, so it fits well in your ceiling cassette units. So if you've got like the 2-way or the 4-way ceiling cassette units, just take down the return grill and the filter, and this fits nice between the filter and the fan inlet. This next product is just a little bit larger. It's good for up to 4,800 CFM. It's also auto cleaning and a wide universal voltage range, 24 to 240. Here's the rare earth magnets provided with the products that allow it to mount right to your fan inlet. So these have 50 pounds of pull force each. So when they snap on, they're very hard to get off. And especially if they snap together, you're going to need some channel locks to get these guys separated. The last auto cleaning product is our DM48, which stands for duct mounted up to 4,800 CFM and auto cleaning. You get this weatherproof enclosure. So now this can mount on your duct and you can treat specific zones versus putting it inside of the air handler. You get this nice display. It tells you the number of days it's operating. It'll say GPS, and if there's a fault, it'll say FALT. If it's cleaning, if you happen to walk by within that 5-second window that it's cleaning once per day or every 3 days, it'll say CLEN in the display. But you can actually remove it from the duct. You take this clear cover off, and then 3/4 of a turn twist, this white part will actually pull out of the duct. And here's what it would look like. You just simply drill a 4-inch round hole, drop that canister into that hole, and then 4 sheet metal screws holds the black part of the housing onto the duct permanently. So that allows you to take the white can in and out of the duct in order to inspect it if you want to do that from time to time, since you cannot see the wiper blade once it's installed. But generally, if there is a fault in the stepper motor, if there are any issues with the circuitry, it's going to say fault on the display. The last product is the iMod. It's a modular ionization device, and it is provided in these 6-inch sections. This is one of our most popular products because it's a semi-custom product. It's available, it's off the shelf. We used to make these bars custom cut to the width of the coil using aluminum channel, but that was a long lead time, 5 to 6 weeks to build these products. Now we have this modular product that we just ship you the sections, and you just snap these sections together for whatever width you need. So whether it's a 2 feet wide coil or if it's 20 feet wide, it doesn't matter. This one power supply can power up to 6 of these bars at any length, essentially. So whether it's 20 feet, 30 feet, you know, we can go up to really long coils, but what we have to look at is the maximum bar length. So you could have 5 10-foot bars, which would be 50 feet. You could have 6 6-foot bars at 36 feet. So you get the idea. You just want to keep the maximum bar length below 50 feet if you are connecting long bars to these power packs. Now, it does only require 15 watts of power, and it's available in 24, 110, or 208 to 240. You just simply set the switch on this particular model to the voltage that you want to use. If you do use 24 volts input, make sure that it's not floating. We like 24 volts that has the hot and a neutral, and the neutral is actually a grounded neutral, not just a floating neutral like you get out of a lot of control power transformers. Now, because this is alternating current or AC output, unlike the other devices with the wiper blade, they do stay clean. From a maintenance standpoint, we recommend that once per year, when you're changing the filters, go ahead and take a rag with some rubbing alcohol. Just walk down the bar and wipe these brushes off if you see any debris. Some people will use a toothbrush just to knock off any debris that they see build up, or you could use a paintbrush. Just don't use an actual wire brush on the system, or you could use a shop vac with a brush attachment. That also works well. So very easy to clean. It's a fiberglass constructed device, so you could take a blowtorch to it. It'll just glow orange, but it doesn't catch on fire or smoke. And so it's very non-conductive because it's fiberglass, and it's non-corrosive. So even in a pool environment, that's not going to impact it. So here we have an example of how it's installed in a larger air handler. You see a bar at the top, one on the middle coil, one on the bottom coil. And we generally recommend 1 bar per coil up to 5 feet in coil height. Over 5 feet in coil height, we go to 2 bars. Or if it's an odor application like a helipad or a airport or somewhere that you need to knock the odors down in a single pass, we always go to 2 bars per coil. So you'd have a 2nd bar midway down across the coil if this were an odor application. But this actual application was at a sheriff's office that had black mold growing on the coils, and this is the post photo that shows the actual black mold's now disappeared. There's still just a little bit left down here, but this whole coil looked like this. And so this was only about 4 weeks in, and they were very pleased because it eliminated the odors they were getting downstream in the space. Out here on the outside of the air handler, you can see how the power pack mounted, and they just plugged it into a standard outlet. You can actually cut that plug off per our UL system rating and hardwire that into your junction box if you want 24 volts or a 208 to 240. Here's some additional examples of the systems. You have rare earth magnets that are provided with these bars, so they just snap the bars right in place. And the other benefit here is ease of installation. It only takes up 1 inch in the direction of airflow, so it doesn't matter that it's a packaged rooftop unit, as you see down here on the right-hand side, or a larger air handler. The systems are modular. They're only 1 inch deep, so they fit just about anywhere that you can fit them into your air handling system. Packaged rooftop units between the filter rack and the coil, that's been the tightest spaces that I've seen, but I've never found a rooftop unit we cannot fit into. Now with these systems, when they're powered, you don't see visible light like a UV light. You don't smell anything like the old ion tubes because we're not generating ozone as a byproduct. So in order to measure and verify they're working, you have multiple options. One, you can use the actual alarm contacts that are built into each one of the devices, which are connected into the microprocessor of the device. It's not just telling you power's been applied like some of our competitors uses a relay that their primary relay coil is attached to the primary power. We're actually sensing what's going on inside the circuitry and then telling the relay to close with our alarm contact. So that's actually a good way to know that it's on and operating properly with no faults. Now, if you want to know the actual ion output, not just what voltage we're sending to the bar, which is what we're measuring with the microprocessor, then you need a handheld meter, which measures your ions. You could also use a space mount meter if you want a permanent solution, or a duct mount ion meter. And both of these meters provide a 0 to 10 volt output back to your building automation system. Now, if your clients don't care about what the ion levels are and you want to actually measure the benefits, you can do that easily through a laser particle counter. So you can measure before and after. You can also use a VOC sensor. So we have some clients putting this VOC sensor, and I highly recommend a photoionization detector type sensor to go upstream and one downstream of our iMod devices and critical applications, and that will trend in real time the actual gases coming into the system and leaving the system, so you can see the effectiveness of the system in one pass in real time. Also, we have duct mount if you use these probes for particle sensing. We also have space mount particle sensing. You just simply take the hose off and mount this device right on the wall, and it reads 2.5 and 10 micron size particles, and is fairly cost effective. The VOC sensors are quite a bit more expensive versus the ion meters. These are also a little bit more pricey, but if you want to truly confirm the ion output and the performance, these are ways you can do it. Now, some people just put it in and walk away. They don't care about measuring and verifying, but you do have those options with our systems. You can tie them into your own building management systems, or you could also use other products that are in the market that can actually read our outputs and then relay that back to you, like a Hobo data logger as an example. So as you leave the presentation, we're coming up here on 7 minutes left before 1. Just remember the acronym POPE again: particle reduction through agglomeration. We make the particles bigger, which makes the air handlers more efficient at capturing them. We break down the gases and odors through oxidation. So don't be confused with how the system works between particles and odors. With gases, we don't physically make them stick together and go back to the air handler to the filters like the particles. We physically rip them apart in the space and break them down. So we're not relying on filters to take the particles or the gases out of the air. With pathogen control, we're treating the pathogens in the air handlers where the devices are mounted, but we're also treating them downstream. Now, one thing I don't believe I covered in this presentation is if you do have a final filter in your systems, like in a healthcare application, you have to put these devices after the final filter in order for the ions to treat the space, because the final filter or any filter that's MERV 8 or greater are easily going to stop these ions. And so if you want to treat your space, a lot of hospitals are putting in 2 sets of bars, one on the coils and one after the HEPA filters in order to treat downstream into that space. If you want to get energy savings and it's not a healthcare application, we can talk about outside air reduction using the indoor air quality procedure. You also get energy savings through coil cleaning and keeping the heat transfer efficiency high, as well as pressure drop low. And the third way we get energy savings would be by using this instead of using carbon, because of the pressure drop and the final filters associated with carbon type systems. With that, I'm happy to pass it back over to Brad and the group for any questions that you may have.
Thanks, Charlie. There seems to be some questions in the chat. Charlie, do you want to go through and address a couple of them? They've been coming in throughout the presentation.
Okay.
I can read them off to you here. James Peterson's asking, is the technology proprietary, or are there multiple manufacturers of similar offerings?
We do have, with our technology, we have 30 patents granted. In total, around 55 to 57, I've lost count, total with pending and granted. And so it is proprietary with the auto cleaning cycles, it's proprietary with the universal voltage, but we do have competition from other needlepoint manufacturers. They just don't have the benefits, nor do they have the ion density that we have with our technology. So we do have competition. Sometimes it's viewed as the carbon, sometimes it's viewed as UV light. those are other competitors we have in the market as well.
Okay. And David Alowitz is asking, I cannot find ASHRAE confirmation of bipolar ionization efficiency against coronavirus. Is this anticipated anytime soon? I think
ASHRAE is not aware of our technology with COVID-19. We're actually putting out the official press release today, which I'm going to be sending it to the people on the COVID-19 task force. Bill Bonfleth is the chair, and he's going to get a copy of it. Whether they talk about it or not, I don't know. A lot of those people on the task force are huge fans of UV light and actually have spent a lot of their work researching UV light from a university level. So we'll see where it goes within ASHRAE. I think they'll talk about it. I saw a post from Dr. Bonfleth a couple of weeks ago on LinkedIn. He said he was going to mention bipolar ionization because it is a hot topic within ASHRAE, but because they have chapters on UV light, carbon, and filters, they haven't really talked much about bipolar ionization. But I think it's to the point now with the data that we have that's third-party certified, they're going to have to start talking about it because it is the first technology with the data, and I don't even know of any UV light manufacturers that has actual COVID-19 testing, but I may be wrong. I've just not seen it.
Okay, and I think Ron's got the next question about incorporating into a package unit. That I think you went over in the presentation, and Ron, you can reach out to a DAC guy, and we can set you up with what you need there. Steve DiGiacomo is asking, SARS corona is a nanoparticulate of 0.0 or 0.113 microns. It behaves more like a gas than a particulate, so it's getting into the return air ducts. And I think you touched on that as well. And we're getting even deeper into this here. Maybe we can set up a call with Steve and reach out and talk to him. SARS corona UVC K factor in air is at 50% RH for 254 nanometer. I don't even know what that is.
that's the germicidal wavelength of the UV light. So what else was that question?
UVC is 0.0037 centimeters squared, with another acronym that I'm not familiar with, which allows me to design certified UVC on the fly, kill AHU RTU systems, which is the equivalent. What is the equivalent K factor for bipolar ionization?
With what we saw in the testing conducted between the Air Force and this lab we talked about in California, we were seeing at the 27,000 ions per cc. That's what we tested at because that's what we're getting into the cabins of the airplanes. And this is specifically for the airplane testing at the time.
Yep.
That's the level we're at there. But in the real world, when we get back into levels that we're going to see in larger spaces, like in hospitals and schools, we're generally around 5,000 ions per cc. So that rate's going to come down slightly. It's not going to be the 99.4 in 30 minutes. It might be 94 or 95% in 30 minutes. But we'll know because we're continuing the testing as we speak.
And then if you were to expand on that time beyond 30 minutes, would the rate go up or stay similar or go down?
As you continue onward, we generally start seeing, more and more inactivation until you'll eventually reach the steady state where even if you look at some of these other technologies, UV light or Lysol, if you pick up a can of Lysol, it'll say it's 99.999% efficient. Nobody says 100% because it's always trying to grow.
Yep. Okay, Teresa Brown, she's got a question that I've actually had multiple texts from throughout this presentation, and I think it's a good one. Once the particulate drop out of the air, is it recommended that the surfaces be cleaned at a certain rate that the particles may have landed on? Can you maybe touch on that and how the inactivation works? And
Sure. So if the particles have already gotten large enough to drop from the air because of the agglomeration process, that means it's been hit multiple times with the ions, so they're likely already inactivated when they drop. We do recommend your standard cleaning protocols to wipe the surfaces as you've been wiping. You don't need to change that. We're just trying to impact what's in the air, but also our testing is on surfaces as well. So as long as the ions are reaching the surfaces, you can expect an activation of the virus on the surfaces being reached with these ions. And that's what we were testing on the planes, is putting Petri dishes out on the tray tables and the armrests and stuff like that.
okay. David Elowitz is asking, what is the size of the agglomerated particle you are generating? Is it 10 micron or larger?
It's many different sizes. So we'll take something as small as the 0.125 or what they said was 0.113 micron virus, COVID virus, and make that charged, but at the same time we're inactivating it if we're charging it, and then it's going to stick to the larger particles. So we can make, let me back up. We'll make the really small particles larger, but if you look at this in a controlled environment, in a clean room, let's say you start off at a certain particle level at 0.3 microns, when you turn the systems on, you will actually see the 0.3 micron particle counts generally increasing like we're generating particles, because we're taking the particles that the meters cannot read and we're shifting them, making them larger. So now they're showing up as that smallest particle the reader can read, which is 0.3 microns. And so we continue that shift, and then over a period of minutes or hours, the 0.3 micron particles start going down because now we're shifting them larger. Some could settle out of the air with poor air exchange rates, and some are going to get back to the filter and be removed.
Okay. So we're kind of going up over our hour time slot here. So there are some more